Good morning, children. So, I hope you are all doing well. Once again, I welcome you all to the Buoyant Study Circle. So, we are in the last part of structure of atom of 10th class physical science. So, we are going to discuss the nature of light, so nature of light and characteristic properties of light. So, as you know that light travels or propagate in the form of wave form, right. So, light travels in the form of wave. So, wave, whenever it travels in the form of wave like this, so it forms crest and trough, right, crest, trough. So, crests and troughs are alternatively formed, right. And also light when travels, it forms electric field and magnetic field, electric field and magnetic field, right. So, light when travels, it forms around it, it can form electric field and magnetic field, right. And these three, that means for example, if we take, this is the direction of propagation of light, right. So, this is the electric field direction and this is the magnetic field direction. That means electric field, magnetic field and propagation of light are, so electric field, magnetic field and direction of propagation of light, these three are perpendicular to each other, right. So, that is why this magnetic, so this light is called electromagnetic radiation, electromagnetic radiation. So, now onwards we usually call light as the electromagnetic radiation, because when light propagates or when light passes in the form of wave, light travels in the form of wave, it forms electric field and magnetic field. That is why this is called electromagnetic radiation, right. So, we want to discuss some important properties of electromagnetic radiation, that is light. So, these are the characteristic properties Number 1, the first characteristic property is wavelength, and the second one is frequency, and the third one is velocity. Okay. So, in 10th class level, so we will discuss the properties wavelength, frequency and velocity, right. So, first wavelength, right. So, light travels in the form of wave, So, when it travels in the form of wave, you know that it forms crest, trough like this, right. Two successive crests are the distance between two successive troughs, right. So, what is wavelength? The distance between two successive crests or two successive troughs, right. So, here So, these are successive crests and these are successive troughs. So, the distance between two successive crests or the distance between two successive troughs is called wavelength, right, and it is indicated by the letter lambda, right, the letter lambda, right. And what are the units of wavelength? So, wavelength, length, that means you can measure the higher values of length in kilometers, meters, centimeters, millimeters, like that, but this is the smaller value, that is why you need micro units. So, the units for wavelength are 1 angstroms, angstroms. So, this is indicated with a degree, and 1 angstrom is equal to 10 to the power of minus 10 meters or 10 to the power of minus 8 centimeters, right. And number 2, nanometers. 1 nanometer is equal to 10 to the power of minus 9 meters or 10 to the power of minus 7 centimeters, right. So, these are the two units that are used to measure the wavelength, right. So, angstroms and nanometers. So, this is the first characteristic property, that is wavelength. So, wavelength is the distance between two successive crests or the distance between two successive troughs, right. So, it is indicated with lambda and the units are angstroms and nanometers. So, 1 angstrom is equal to this one and 1 nanometer is equal to this one. Whenever you come across the conversion, 1 nanometer is equal to 10 angstroms. 1 nanometer is equal to 10 angstroms. For example, if you are asked 460 nanometers is equal to how many angstroms? So, just multiply with 10. So, you will give the answer 4600 angstroms. For example, whenever angstroms are given, for example 7600 angstroms are given, then how many nanometers is it equal to? So, by 10 divide with 10, you will get 760 nanometers, right. So, whenever you want to convert nanometers into angstroms, multiply with 10, and whenever you have to convert angstroms into nanometers, divide with 10. So, that means 1 nanometer is equal to 10 angstroms, right. So, this is the first property, that is wavelength. And the second one, that is frequency. Second characteristic property of light is, or electromagnetic radiation, is frequency. So, what does this frequency mean, right? So, first you have to clear that one crest and one trough, one crest and one trough is called one wave, right. One crest and one trough is called one wave, right. So, if I am observing at a particular point in particular time, how many waves are crossing through that particular point? How many waves are crossing this particular point in the given time, right. So, that number of waves that are crossing through a particular point in unit time is called frequency, right. So, the number of waves, that are passing through a particular point in unit time is called frequency, right. So, whenever one crest and one trough is passing this point, you have to count it as one wave. So, in that way, in the given time, how many waves are crossing that particular point, that is called frequency. So, this frequency is indicated with the letter nu, right, and the units are cycles per second or hertz, cycles per second or hertz. Okay. So, this is the second characteristic property of light, that is frequency. So frequency is nothing but the number of waves that are crossing through a particular point in unit time, right. So this is indicated with the letter nu, and units are cycles per second or hertz. Okay. Now, for example, what is the relation between these two? What is the relation between these two? That means frequency and wavelength, right. For example, I am writing different types of waves. So this is the smaller wave, this is somewhat bigger wave, and this is somewhat bigger wave, and this is more bigger wave, like this, right. So if you consider different sizes of waves, that means different wavelengths. So as size increases, that means wavelength also increases. Now tell me, children, which type of waves cross a particular point in more number? That means if the wave is smaller, the number of waves are more that are crossing through a particular point in given unit time. For example, if this is the bigger wave, so this bigger wave can cross this point in smaller number. As the size is more, the number of waves that are crossing the particular point is less. That means wavelength is inversely proportional to frequency, inversely proportional to frequency. The smaller the wavelength, frequency is more. If wave is smaller, more number waves cross a particular point. If wavelength is great or higher or big, less number of waves cross a particular point. That means you came to understand that wavelength and frequency are inversely proportional to each other. That means frequency is inversely proportional to wavelength, right. So whenever you remove this proportionality constant, you will get a constant called c. So this c is nothing but velocity of light, right. So what is the velocity of light? In general, you can write 10 to the power of 3 into 10 to the power of 8 meter per second, or 3 into 10 to the power of 10 centimeters per second. It is a constant value, right. So among these three characteristic properties, the relation is nu is equal to c by lambda. Here nu is equal to frequency of the given electromagnetic radiation, and c is the velocity of light, and lambda is the wavelength of that electromagnetic radiation, right. So if lambda is given, you can calculate frequency. If frequency is given, you can calculate the wavelength, right. So in this way, you can relate these characteristic properties, right. So children, I hope you came to know that you can now define the three characteristic properties: wavelength, frequency, and velocity of light. Okay. So let us do some calculation, right. For example, find the frequency of electromagnetic radiation whose wavelength is 3000 angstroms. 3000 angstroms, right. So here wavelength is given. So wavelength is equal to 3000 angstroms, and velocity of light is 3 into 10 to the power of 8 meter per second, and you have to calculate frequency, right. So as velocity is taken in meter per second, you have to convert angstroms into meters. So 3 into 10 to the power 3000 into 10 to the power of minus 10 meters, right. So you know that this will become 3 into 10 to the power of minus 7 meters. So these 3 cancel here. So 3 into 10 to the power of minus 7 meters. Now nu is equal to c by lambda. So c is 3 into 10 to the power of 8 by lambda value 3 into 10 to the power of minus 7. So 3 gets cancelled, and 10 to the power of 8, when you bring denominator value 10 to the power of minus 7 into numerator, it will become positive, and the value is 10 to the power of 15 hertz or cycles per second. So now what is the frequency of the given electromagnetic radiation? 10 to the power of 15 hertz. Okay. So in this way, if wavelength is given, you can calculate frequency. If frequency is given, you can calculate wavelength, right. So these are the characteristic properties and their interrelationship, right. Now you know that light is also a form of energy. Light is also a form of energy. So then how can you calculate the energy of light, right? So this is given by Max Planck. Max Planck, in Planck equation, E is equal to h nu. E is equal to h nu. So here E is the energy of the electromagnetic radiation and frequency nu. That means energy is directly proportional to frequency, right. So that means frequency increases, energy increases, right. So energy is directly proportional to frequency. So when you remove this proportionality, you will get a constant, that is h. This constant is called Planck's constant. Planck's constant, and whose value is 6.628 into 10 to the power of minus 34 joule second, 10 to the power of minus 27 erg into second. So these are the Planck's constant values, right. 6.628 in 10 to the power of minus 34 and minus 27. So in joules and ergs, right. So if you know the frequency value of electromagnetic radiation, you can calculate the energy of electromagnetic radiation. When you substitute the Planck's constant value in joules, you will get the value in joules. When you substitute the value of Planck's constant in ergs, you will get the energy in ergs, right. So this is in this way, from Planck's equation E is equal to h nu, you can calculate the energy of electromagnetic radiation also, right. Then so according to wavelength and frequency, different types of electromagnetic radiations are arranged, right, according to their wavelength and frequency, right. So radio waves, microwaves, infrared waves, right, ultraviolet, visible, ultraviolet, X-rays and gamma rays and cosmic rays, right. So these are the different types of electromagnetic radiations or light waves that are available in the nature, right. So in this way, lambda value, and in this way frequency value, right. So lambda value increases from left to right and frequency value decreases from left to right. So when different electromagnetic radiations are arranged according to their wavelength increasing order or according to their frequency decreasing order, this arrangement is called, or the entire range of wavelengths or the entire range of frequencies is called electromagnetic spectrum. Electromagnetic spectrum, right. So now what is electromagnetic spectrum? So different types of light waves, when arranged according to their wavelength or when arranged according to their frequency. So this entire arrangement is called electromagnetic spectrum, right. So see here, you cannot identify these light waves with your naked eye. So these light waves are not detectable our eye. So only visible light can only, our eye can detect only visible rays. So when you observe the visible rays, there are 7 colors, right. So violet, indigo, blue, green, yellow, orange, red, right. So from this to this side, left to right, wavelength increases, and from this to this side, frequency decreases. So, this arrangement of visible light according to wavelength and frequency is called visible spectrum. Visible spectrum. So, now what is visible spectrum? So, different types of lights that are available in the visible region. So, these are VIBGR, you generally call it as violet, indigo, blue, green, yellow, orange, red. So, when these are arranged according to their wavelength and frequency, this arrangement is called visible spectrum. So, our naked eye or our eye can detect only this range of wavelengths only. The remaining light our eye cannot detect. Okay. So, this entire arrangement is called electromagnetic spectrum, and this visible region is called visible spectrum, right. So, children, this is the general information about the nature of light. So, as we discussed the structure of atom. So, once again we want to recapitulate what we have discussed in structure of atom. So, in generally we come across the subatomic particles, right, and the models, Thomson model, Rutherford model, Bohr's model, Sommerfeld model, and quantum mechanical model. So, just go through them, and then we discuss the quantum numbers, which gives the complete address of the electrons, and then we already discussed the electronic configuration and how to write the electronic configuration based on Hofbauer, Hund's and Pauli's principle. And then this is the extra information about the nature of light and characteristic properties of light. Okay, children, this is the thorough knowledge about the atomic structure or structure of atom in our physical science 10th class. You just go through this and then try to answer all the questions which are available in the textbook reflection of your concepts. Okay, thank you and all the best. Stay tuned to Boyan Study Circle.